Hello and welcome to the next episode of the Klingberg Wing Mark II development. I'm Raul Klingberg, your host. Today we're going to talk about covering. Let's get on with it. Okay, welcome back. I have in front of me here, although it doesn't fit well in frame, the right wingtip of my glider, and this wingtip is complete end to end, and this is a flight component, and it's ready to use. I've had this finished for 6-9 months, something like that, and I wanted to get these done early so that I could let the finishing and covering method sit around for a while, see how it holds up as I move it around the shop and so forth. I generally keep bubble wrap on it to kind of protect it, but I'm just kind of testing the durability of the structure and what does it handle like. And this whole panel was this way. I think it weighs 5.5 pounds, something like that. Not much. It's 6 foot long, and it's got all the fittings in it and so forth. It's ready to go. And one of my well-loved patrons said, "Hey, I'd like to see about covering. How's the covering work out on these things? How are you doing it?" So I thought I'd do a little video to explain the covering methodology behind these wingtips. I went with fabric on the aft portion. This is carbon fiber and fiberglass D-tube up front that you've seen me talk about in other videos. And the fabric on the back is Oratex. Now, the structure inside is foam ribs with basswood cap strips. I'll put some pictures up here so you can see the guts of this. And at the root end, this one actually has a composite trailing edge, which I don't like at all. It was strong enough, but it was expensive to make, difficult to make, fragile to work with. The other wingtip has basswood back here. Fraction of the cost, easy to work with. Just no reason to use composites if you don't have to. Basswood, wood. Wood's nature's composite structure. It's really good stuff when appropriate. And at the root area here, I have some 16th-inch thick basswood sheeting. And it's spliced together here normally like you would with a model airplane. And it's got some cutout here that's curved here to distribute the loads. I'll put up another picture, you can see the inside. The main thing that this sheeting does, there's a rib here, and this sheeting goes on here to take the compressive loads that you experience, or the tension loads I should say. As the fabric shrinks and it puts tension on here, you would normally pull this rib in and buckle it in. You don't want to do that. So the traditional model airplane method here is to sheet this area, and that sheeting, because the grain runs this way, takes those loads just fine. And then the cap strips themselves on the ribs, they run this way. And how it works with aircraft, if you haven't ever thought about this before, I'll explain it. Obviously this whole surface, it has load on it, and we know that with this airfoil, 75% of the loads and aerodynamics are done by the time you get to the spar. So this composite D-tube has the majority of the loads on it. And the loads back here are relatively minor. They're really quite low, even at high Gs. But how it works is you have lifting forces on the whole surface. So this fabric is trying to lift up. It's firmly attached to the ribs, so those lifting loads are transferred into the cap strip as a tension this way. You're trying to pull it up like this, and that tension load trying to lift it puts the cap strip in tension this way and transfers the loads up to the spar. Now, and into the trailing edge. Now, the cap strips are not butted to the trailing edge and butted to the spar. That would be a bad plan. There's actually a flange inside here that the cap strip is bonded to. Nice bonding area so that it can't pull off of that. And then at the trailing edge, back here, between the cap strip and the trailing edge, underneath, between the wood and the foam, there's a strip of 1/64 inch plywood that glues to the cap strip and glues to the trailing edge and transfers the loads from the trailing edge area in this area so that the cap strips can never detach from the trailing edge or the leading edge. And the cap strips are bonded to the foam. So you just gather up all the loads that are here and transfer them into the cap strips, and the cap strips carry them up here. Now, the cap strips would do that job too if you had a control surface on here. As you put loads on the control surface, it puts loads up and down on the ribs, puts the cap strips in tension and compression, and transfer your loads that way. But your flight loads are moved in via the fabric. So in order to make this system work, we got to make sure that the fabric is firmly attached to the cap strips and the fabric can't fail in flight. Now, there are many, many types of aircraft fabric out there that are available, and most of them involve a lot of work, painting and finishing. There's some new stuff that's come out recently for the ultralight world called Oratex. And initially it was not certified, and it was being used up in Canada and some other places. It was certified in Europe way before the United States. But it recently got certification. Let's see, I think I have a piece of it back here. Now, its main advantage is that it comes with a color on it already, and you can get this in a variety of colors, and it's certified for aircraft use. And it's wide enough here to do my job. And you apply this by putting on their adhesive, the Oratex adhesive, and you brush it on your framework, and you put it on the cap strips and trailing edge, and then you iron it on. And this is a fairly traditional methodology. You can go out and find similar methodology for like Stitz fabric, and you can put it on a high-speed home-built aircraft. And it's quite often just literally glued to the airframe, and then it's shrunk with ironing. And there's certain ways that it's applied and certain width areas that you need for putting on the adhesive and all that. But it's a well-known process and holds up well over time and takes all the loads, and it's heat shrink fabric. But then you have to go and paint it. Paint weighs a lot. This stuff has the color applied to the fabric in the factory when it's being manufactured, and you can scrape it, the color doesn't come off. Heat shrinks with an iron. You want to patch it, you can iron on a patch. Pretty cool stuff. And I bought some of it and I started playing with it. And the wing sample's down on the floor over there. I won't show it to you now, but what I discovered is that this stuff is mostly meant for metal airframes. It can be used on wood too, but it's really meant for metal. And they have very specific instructions on this. You have to brush it on, let it dry, put on a second coat, brush it on, and let that dry just the right amount. Don't let it dry for too long before you put your fabric on and shrink it out. And you also have to apply it to the fabric. There is no adhesive on this fabric at all. So you kind of got to lay out your fabric. You do a pencil layout on one side, and I guess you could take a spray gun on the back side here and thin this stuff out with whatever you can thin it with, spray it on there, and then you have adhesive everywhere. But I went to the trouble of doing my sample. I laid it out, pencil marks, brushed it on there within the pencil marks. I have a hard time staying within the lines ever since I was a kid. Let me tell you, it's messy. It's gooey, it goes everywhere. I had a hard time keeping it aligned properly. It's just okay, so this is certified for aircraft, and I'm working with it, and I figure I'll learn how to do better with it. So then I got done, and I got my sample, and I ironed it on. And darned if, wherever the glue is, the fabric's really rough. It's got all of these wrinkles in it, and it's the brush strokes that are in the adhesive. It never flowed out. It didn't flow out and get rid of the brush strokes, and they just get ironed right into the fabric. I thought, on an ultralight aircraft, metal airframe, maybe it's a 1 or 2 seater, maybe it's like one of those 3/4 size World War I fighters, but built out of aluminum. They're pretty cool. Nobody would care about those little wrinkles that are in it. Make no difference because it's a kind of a rugged aluminum airframe. It's not that smooth. I got a glider. I can't have wrinkles in the surface. I don't want wrinkles. It wrecks my aerodynamics that I work so hard to get. And I thought, cool system, but I don't like it. Not for this application. So, Oratex, out. Got rid of that. I thought, I could just be crazy about this. I could just put MkII on it. And oh my God, people would just freak out if I got out to the field and they come up and they go, "What's this?" And I go, "MkII. I ironed it on there, I'm good to go." And they'd all freak out. It's like, "You're gonna die. It's gonna just come off in flight." And I'd give them all kind of arguments about how fast model airplanes fly, and MkII's fine. And then somebody'd remind me, "Well, MkII comes loose after a while." But I knew that you can actually use MkII. And I'll put up a picture here. Here's an ultralight aircraft, twin engine, that a guy did as an experiment to see how you could inexpensively build your own airplane out of spruce, and he covered it in MkII. He flies it that way. Unfortunately, he's passed on. He passed on early. But he did some amazing work while he was here, and he proved to everybody that you can do an ultralight aircraft covered in Monaco. It flies just fine, as long as you keep within the load capabilities of that material, which is kind of the overarching theme of this series. Design with whatever you want to use, just stay within the capabilities of that material. And, you know, Monaco, cracks, poke a hole in it, whatever, hey, packing tape over the outside, you're good to fly for the rest of the day. Get home, get some goo on, take the packing tape off, iron on a patch, super, good to go. Well, in the model airplane world, they have fabric coverings for some of the quarter scale planes, some of the giant scale models. And I knew this stuff existed. It's called Cover-Ride or Ultratex and all this other stuff. And you iron it on just like Monaco, and it already has adhesive on it. So my winglets I built and used Cover-Ride. It was this product that was available at the time. And in fact, here's an additional adhesive that you can buy that goes with it, Balsa-Rite from the Cover-Rite people. And in the middle of my project, I found out they're not making Cover-Rite anymore. And I liked it because it had a nice white gloss finish to it and ironed right on. Super duper. I thought, oh my God, I'm screwed. I'm going to go back to the Ortex and I'm going to have to spread all that glue on its foot. And I did some searching around and I run into this, another source of Ortex, and it's from Balsa, USA. And it comes in 25-foot long rolls, 75 foot. You get a big roll of this stuff. And I look at the price and I go, oh, it's half the cost of the Ortex stuff. It's got the color on it, and it's got adhesive on it already. Half the cost. And I buy some of it, and I get it. Let's see. It comes on a roll like this. It comes on a roll like this, and it's got a, this actually has a paper backing on it that just comes right off. You take that off. In fact, this is the roll left over from cutting this piece out to go on the wing. And it's the shiny side is not the outside. That's actually the inside. And that's the adhesive that's on there. It's already on there. And I'm looking at this stuff, and you know what? They're both called Ortex. Ortex fabric. And I was like, man, that stuff's strong. Get the other Ortex. Well, they don't feel exactly the same. This stuff is a little more stretchy. The model stuff, it's got a little more stretch to it. You can pull on it, it starts to stretch. You can't do that with the aircraft rated version. Much stiffer that way. But when you go and tear this stuff, they both have about the same tear strength. I don't know what the numbers on it, but close enough. It's like, why should I pay double and have to paint all the adhesive onto the fabric? It's just dumb. It already comes with adhesive on it. And you know, this goes on to giant scale model airplanes. And there's some giant scale model airplanes at 100 miles an hour plus. And this stuff doesn't come off because when you put it on, you're putting on adhesive on the framework also. And I thought, I wonder if I can use the Ortex adhesive with this stuff. And I went and did it. Had the same problem. Got the wrinkles in it. It's something about this adhesive, how it dries and whatever. It doesn't flow out. But I know we got Cover-Rite, right? You can use that. You put that. This is often used on fiberglass structures that you want to iron on a covering. And usually the adhesive that's on this covering doesn't stick very good to composite surfaces. So you would paint this on first. And this is really thin. It's almost water-like. And it flows out really smooth. No wrinkles. But my favorite is Sig Stix-It. A little bit thicker than the Cover-Rite stuff. But this is designed for attaching fabric coverings on model airplanes. And I like it because it's designed to go with wood. This Ortex stuff really seemed to be kind of designed to go with metal. You can use it on wood too, but it seemed to prefer metal. And it sort of makes sense, a lot of ultralights, metal airframes. This stuff has a viscosity and characteristics of the glue. It really penetrates into the wood. And you only have to put on one coat. You brush on one coat, goes into the wood, you can see the wood change color, let it dry, and you got your adhesive on there. And then I put on the covering and iron it on, and man, I've tested these joints. They're really strong. You probably peel the wood apart before the fabric separates from the framework. Might not be certified, but heck, at the upper end, I'm going to be going 75, 80 miles an hour. It's fine. The loads back here are really, really low. I think I got absolutely nothing to worry about. And because this is a little extra stretchy, Well, when you set it down on the ground, if there's something on the ground that wants to poke it, well, it's going to give before it punctures. And if it does puncture, packing tape, keep flying that day, go home and fix it. And if it gets beat up after a year or two, take your heat gun, heat it up, peel it off, sand the framework, put on new adhesive, put on new covering. It's low cost. You can afford to do that. Now, in terms of this airframe, how I've done it for this airframe, I'll put up some pictures as I go here. What I do first is I make a template out of paper that runs from, you know, an inch or so onto the composite structure here, onto the D-tube, and then a good inch or so past the trailing edge. And I cut out that paper template, and then I tape the paper template to the back side of the model airplane Ortex fabric and cut out the fabric. And that way I got nice straight edges, essentially two size, and I don't have any errors of, oh, it was just a little bit too small because I slipped while I was cutting it while it was laying on the wing and it moved on me. Paper template's better. So then I then prepare the framework by applying the adhesive, you know, and let it cure for the recommended time. Start on the lower surface, and I basically just tack it in place, just like you would cover a model airplane, tack it in place, and then iron out the edges, get the edges like this all the way around, and then heat gun it, you know, to shrink the fabric up tight, get a nice drum tightness on here, and then go back and iron everywhere that you applied adhesive on the framework to get it bonded down tight, trailing edge, ribs, and up here. You're on the bottom, the extra comes up, wraps around, and gets bonded to the top of the trailing edge here. And this is just a butt finish on the end up here. When you put on the top, it comes here and wraps around underneath. So you have essentially this, and it's well attached at the trailing edge. Now, if you've watched, you know that my philosophy on the wingtips and the winglets is that they are expendable. In order to keep the aircraft really light, this is built for aerodynamic loads mostly and reasonable handling. But in terms of rugged banging around and throw it in the truck and stuff like that, it's really not made for that. So this has been built really light, and if it does get damaged, well, it's relatively inexpensive. You can build a wingtip like this for $500, $700, something like that. And if you have the molds already, to build another one, you can probably do it in a week. 1 week, you can build yourself another wingtip. So it's not a big deal. And on the winglets, they're symmetrical. So I suspect a lot of people will just build an extra winglet, keep it in the storage container, and if you have to happen to prang one while you're out in the field, you just throw that one away and put a new one in. So the winglets, the philosophy on winglets and wingtips, they're expendable if need be. Hence the really lightweight structure and why I'm using fabric and all of that. So that is how the fabric's applied back here, what fabric I'm using and how I apply it. And if you got to go around compound curves, it does that really well too. And then on the front of this thing, if you haven't seen the other videos, do I have it out here? Yeah. No, I didn't bring it out. I didn't bring out a roll of it. But you can get these long, very long rolls of Oracal 651 vinyl. And it's used for making vinyl lettering on outdoor signs. The stuff is rated UV resistant for 6 years outdoors. It's tough stuff. It's really inexpensive, got a nice stretch to it, and it's what I have on the leading edge here. And it's very similar to the vinyls that they use for the car wraps right now, for that advertising and different designs on your car. And you can apply it wet or dry. I prefer the wet method, which is a little bit of soapy water goes on the surface. And in the end of the video here, I'm going to throw in a segment that shows me doing the leading edge here. I struggle a little bit, but it's a practice thing. Basically, you start at the leading edge, and the D-tube is wet, and you lay it on there, and you start to squeegee all the water out with a squeegee like this, and you go like this. Now, that I put on second, because I'm going over the top of the Ortex fabric and then trimming the end of the Oracal. Don't get them confused, Ortex and Oracal. Trimming the end of the Oracal. And that's why I got the little pinstripe on here. The pinstripe actually hides the seam. Makes it look a little prettier, you know, typical modeler in me. But I got a good, you know, 3/4 inch overlap here. So the Oracal, because it sticks to the D-tube really, really good, helps hold the Ortex fabric down and provides a smooth aerodynamic transition here. And the transition from a laminar boundary layer to turbulent boundary layer on this particular airfoil actually occurs right about here on this airfoil, so that it's already the turbulent boundary layer by the time we get to where the seam is. So if we have little bumps here, neither here nor there, because we're already into the turbulent boundary layer. If you had a laminar flow airfoil, you don't want to do that. This would probably trip the flow. But if you're putting a laminar flow airfoil on a flying wing, I need to talk to you. In fact, I'll probably do a future segment on that. Laminar flow airfoils and flying wings are not exactly a match made in heaven. I think everybody who's done a number of flying wing designs has tried laminar flow one way, somewhere along the line, and they end up scratching their heads going, well, that didn't work out as well as I thought. And I've done some research into that, and I think I know why, but I do not recommend laminar flow airfoils for flying wings, unless you do a bunch of other stuff to compensate for it. So this is a standard turbulent boundary layer transition at the quarter chord or third chord. That's right up in here, so it's not a problem. So I have put this Oracal on a test sample of the D-tube, put it on the roof of my house for almost a year, and just let it sit out in all weather conditions. And I had half of the D-tube exposed and half was covered. Wow, what a difference. The fiberglass takes, and the foam take quite a beating in the UV exposure. The Oracal, nothing. It is just really resists that UV. And the foam and fiberglass underneath were just fine, no discoloration, no changes in, apparent changes in material capability. So that's a good thing. And on the plus side, if you get a hold of the edge of the Oracal and you start applying a little bit of heat or a little bit of gentle solvent on there, like that orange, whatever solvent that you use for adhesives based on orange peel, you can remove this Oracal. If this gets scratched up and dinged, you can peel it off and just put new stuff on. And when you're peeling it off, it generally doesn't, now I haven't tried it after 2 or 3 years, but I've been able to get this stuff off without leaving any residue behind. It's pretty cool. So you can recover your whole wing fairly easily and inexpensively. And let me tell you, this Oracal stuff, because they make a bazillion yards of the stuff for the sign industry, it's really cheap. Cool stuff, nice and shiny, goes on smooth, and once you learn how to apply it, it's pretty cool. So that's the covering methodology for my wings. Fabric, model airplane fabric applied with extra adhesive. The model airplane fabric, highly similar to the certified ultralight aircraft fabric, applied using the same methodologies. And then Oracal out of the sign industry up front, a combination of unconventional yet appropriate materials for the task at hand. And as a little aside, I thought before we run into the video of me putting the Oracal on the front, I often thought about, what if the covering blows off of here? You're hauling along, you get in some weird aerodynamic vent, you got a big pull up, and pow, the fabric comes off. It's not going to blow a hole in it, it's just going to peel off. I had to stop and think about that and go, oh, wait a minute. For this airfoil, the portion of the wing that has fabric on it is really all about drag reduction. This part of the wing doesn't generate hardly any lift at all. All the lift is up here. This is a front-loaded, cambers way up at the front of the airfoil to get the right pitching moment. This is the part of the aircraft that's doing the lifting, where I have the D-tube. You could probably strip the fabric off of this thing, and you're going to generate 80% of the lift that you had before. And it's going to be really draggy. So you're going to have a really lousy L over D, probably like an original Regala wing. You're going 4 to 1, headed for the ground, you got fabric flapping, but you're not going to fall out of the sky. So you could actually, if you blow it off of one side and not the other, well, then you got a little banking problem. Hopefully you have enough aileron left to compensate for that. But I think for the most part, even if this got damaged in flight, the aircraft's probably flyable and you get it back on the ground. Worst comes to worst, that's why we have those ballistic parachutes. So we'll do a little flip around here. We'll go to the fast forward of covering the front here. Hope you enjoy it. I hope you liked this episode. I hope you learned a little bit along the way. And you can see that you can use some unique materials out of other industries and apply them appropriately and get a really good, nice solution for your aircraft design. So always keep an open mind. In the meantime, fly safe. Catch you on the next episode. Bye for now.